Hi guys, welcome to another tutorial video. In this tutorial video I will show you how you can compose a matrix when you're given a sum of column sums and a column of column sums and a row of row sums. So I think it's better to just draw this visually. So let's just set up Paint. Okay, so basically what we're given is a vector, and this vector contains numbers, and these numbers have to be the sum or the sums of each entry in a matrix. So we don't know which elements are in this matrix, but we do know what the sums of the columns and rows is going to be. So basically what you would right now try to do is you try to find numbers that we can place here, such that if you sum up these three numbers you get 6, and if you sum up these three you also get 6. If you sum up these guys then you get 7. If you sum up these guys then you get 9. So basically you're looking for, like solving a puzzle, and you're trying to find out how you can populate this matrix with values so that all of these values return these sums. So essentially it's like solving a set of equations. So let's actually work on a solution. So the problem statement says we're given a row sum column sum vector, we need to compose a matrix, and we need to optimize for auxiliary space. So basically we should try to use not a lot of space, and we should try to minimize that. So I suggest maybe pause the video here, hit the subscribe button while you do, just joking, so that you can think about the problem yourself, and then I will work on a solution. So yes, I hope you pause the video, you might have thought about it, and a solution which is, actually it's not very difficult, but it's not like obvious either, would be to basically start with a matrix. Let me just also remove these guys. So we basically start with a matrix filled with zeros, and then what we do is at the first entry we put the minimum value of this column sum value and the row sum. So if this value would be 3 and this value would be 1, then we would put a 1 here. And then we would subtract the value we put here from this value right here until we are done. So let's basically try to use this. Essentially it's kind of like a greedy strategy. And I'm going to call this function compose matrix, and it takes a row sum vector and a column sum vector. And so it might be good to first just define the dimensions of the matrix, which would just be the rows would be the length of the row sum vector, and the columns would be the length of the column sum vector. Then I'm going to also define a matrix of zeros, and I'll use list comprehension for that. So 0 for column in the range of columns. So basically that would be an empty column, and then we're going to repeat this for all of the rows. So this looks very fancy, but basically just generates a matrix of zeros with the given size that we need. Okay, now let's iterate over each entry. I have a tendency to forget the in statement in the matrix. And you'll just iterate over the rows first and then over the columns, but basically you could do it in reverse, it doesn't matter. Now let's use a strategy that I just showed you using the picture. Basically we're going to compute the minimum value of the jth column sum and the ith row sum, and then it's important we're going to check that the minimum is greater than 0, because if it is 0 then that means we should just add in the 0 element, right? So I'm sorry, if it's less than 0, then we should just put 0 at this position, because we're no longer going to add anything in. We'll make it worse. If the minimum is greater than 0, well, that means that we are going to take that value and put it at the ijth entry, and then we're going to reduce, or basically subtract, the value we just added in from the column sum and also from the row sum. So I'll just discuss this once because maybe it's not entirely clear. And that would, I guess, be it. After this, we can just return the matrix. So I'll just discuss this once. Basically, we initialize the lengths here, and we initialize a empty matrix, and then we iterate through each row, and for each row we iterate through all of the columns, and then basically at each entry we look at the minimum value of the column sum and the row sum, and we say if m is greater than 0. So if this minimum value is greater than 0, well, that means there is still something left there. It's not yet 0, because when these column sums and row sums essentially go to 0, that means we have filled up the row with the right elements and the column also, so then it's fine. But if it isn't fine yet, then we basically add this element, put the number m, and we remove it. Then if the m is 0, well, then essentially we don't want to add anything because we have already found the numbers. We just need to add in 0 so that it doesn't change. So now let's take a look at the time complexity and space complexity, or auxiliary space complexity we have here. Essentially we have basically two constant time operations. Then we initialize a matrix, and this would be basically the space complexity would be O of rows times columns, because we have rows times columns, different entries. And then if we iterate over the rows and the columns, and then these here are just constant time operations. So the time complexity would also be O of rows times columns. And so we could find a better solution essentially, or not better, but a faster solution if we used a heap. However, we would have to use more memory in that case. So for this specific formulation, this is actually just fine. Yeah, they call it auxiliary, but just space complexity, I guess, just fine. So I hope you learned something from this video. If you're not subscribed yet, consider subscribing. Like the video if you liked it. If you have any problems you wish to see solved, leave them in the comments below, and I'll see if I can solve them. Thanks for watching.